In this video, I'm going to be taking a look at WAMAP assignment 5.1. This is hopefully going to be a review for you, but if not, you're going to get a little crash course here on how to graph a few of these very common parent functions, because that's what this assignment is all about, graphing parent functions. Now, as usual with our WAMAP assignments, your questions might be in a different order. Although in this particular case, you will have these exact questions come up somewhere along the line because I've picked some very particular ones. So the first thing I want you to note here is that we're being asked to graph y equals x squared. So that means the first thing I need to do is know what the shape of x squared is. Now, if you want to, you can actually do this by plotting some individual points to see where they go. It doesn't mean you're actually going to plot them on WAMAP, but you can plot them on paper to see what it's going to look like. If you did that, I'd be saying, okay, well, I'll try an x value of 0, say. 0 squared is 0. And so I'd plot a point right here at 0. And then I could try putting 1 in for x. 1 squared is 1. And then I could try plugging 2 in for x. And 2 squared is 4. And why am I squaring everything? Because my original equation up here is y equals x squared. And so that's telling me I got to square them. And so then if I continue doing that, 3 squared would give me 9. And I could do the same thing on the left side. Negative 1 squared is a positive 1. Negative 2 squared is 4. Negative 3 squared is 9. Notice the shape that that's given us. When we see a graph that is y equals x squared, that tells us that it's going to be a parabola shape like this. That's the formal name of this, but sometimes people will just call it that U-shaped graph. But once we know what the shape of the graph is, now we can go ahead and graph it here on WAMAP. We got a whole list of tools down here that we have to choose from. We got to pick the right one first. As I take a look through those, the only one that looks like this is this graph right here. So the first thing I want to do is I'm going to pick that button, and then I'm going to put the very first point at the vertex of my parabola. And now that I've clicked that point at the vertex, I now click one other point on that parabola. And as you do that, you'll notice that it's moving your graph around as you plot that other point. It doesn't matter which other point you can go to, you can pick any of them. So like you could go over 1 up 1, or you could do the over 2 up 4 that we talked about, or even over 3 and up 9. It doesn't matter which point because you'll notice it makes the same parabola no matter what. Once you plotted that, then your parabola is locked in place. So then you can go ahead and submit your question. In my next problem, I have y equals the absolute value of x as my equation that I need to graph here. Absolute value means make whatever it is inside positive. So if we're going to be graphing the absolute value of x here, I can choose any values I want for x, but the output is always going to be a positive number, or at least it won't be negative. So for instance, I could go over and I could choose 0. Well, the absolute value of 0 is 0. What about 1? The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. Because if it's already positive, it just stays positive. And you can see where this is going. No matter where I go on that right side, it's going to keep going up 1 and over 1 there. What about on the left side? If I go to negative 1 here as my next x value, the absolute value of negative 1 is a positive 1. And so then that would be negative 1, 1 as my coordinate point. If I go to negative 2 next, the absolute value of negative 2 is positive 2. Negative 3 becomes 3, and so on and so forth. And so you can see here that we end up with a graph that is a V shape. In order to replicate that now on my graph here, I'm going to select the absolute value symbol, this particular graph shape down here. And then now that I've selected that, I'm going to put my first point at 0, 0. And then just like before, as I drag it around, I can put this other point anywhere that fits on the graph. So I'll pick one of those points and then draw the graph through it. Now, of course, remember, you don't need to actually be plotting individual points on WAMAP for this because it's giving you the entire graphing tool to use. Although you will plot a few points in later problems, as we'll see. All right, my next problem, and actually the last of the three function types that are going to be coming up in this assignment, is this one, y equals the square root of x. So again, I'm going to start by just plotting some points here so I can get a feel for what the shape should look like to make sure you understand how it goes. So first up, I would just try some x values and plug them in. So the square root of 0 is 0. So again, I'm going to start at 0, 0. Notice all of these started at 0, 0 in this case. Not every graph does, but all of them that you're working with in this assignment do. Then I might go to 1. The square root of 1 is 1. That's another commonality. All of them in this assignment include the 0.11. But this is where things start varying. Next up, I might do the square root of 2. Except notice the square root of 2 does not have a nice pretty answer. It's a decimal. You'd have to put it on your calculator and then try to estimate about where that is on the graph. You don't need to mess around with that. So don't worry about doing the square root of 2. So I just go on to the next x value. Could I do the square root of 3? Nope, that would also be a decimal. What about the square root of 4? Yes, we can do the square root of 4 because that equals 2. So that tells me then the point 4, 2. That is over 4 and up 2. And then I would think about, okay, well, I can see that some of them are giving me decimals. What's the next number where I can take the square root of it and get a nice pretty whole number? Well, that must be the one that would give me 3. Square root of what is 3? That would be the square root of 9. So I'm going to have a point here at 9, 3. That is over 9 and up 3. All right, great. What about, that's the positive side. What about the negative side? What if I next go to the square root of negative 1? What does that equal? Well, actually, this is a bit problematic because we cannot take the square root of a negative number. Square roots mean what number times itself equals this. And a positive 1 times a positive 1 is a positive 1. And a negative 1 times negative 1 is also a positive 1. There's no way to multiply a number by itself and get a negative like this. And so the square root of negative 1 has no actual value to it. It's actually an imaginary number, which is something we'll touch on later. And so because of that, there is no graph to the left of 0 because they're all in the negatives. All right, so you can kind of see the shape of the graph there. Now I want to take a look down at my list of possible options here, and I want to look for a graph that looks like that. And I do see that I have one that I can use here. That one looks just like the square root graph, and so that's what we're going to be able to use. So you go ahead and you select that particular graph, and then I put my first point at the starting point, which is at 0, 0. And then once again, you notice as I move it around, I'm moving it, and there's nothing to the left. That's good. That's what we wanted to see. And again, I can put it at any of these points that I have here. As long as it's a point on the graph, you can put it in any of those. It's the starting point that has to be much more precise. Once you've done that, then you go ahead and plot it, and then you can click submit, and you are done with this problem. As we continue on in this assignment, you've actually now worked with all three of the different types of graphs. The only difference is that for these next few problems, you're going to be asked instead to plot individual points for it, rather than drawing in the graph. You'll notice down below here, below our graph, there's no tools, there's no curves to choose from. There's only dot. And so we are going to have to plot those individual dots. But thankfully, we already know how to do that because we are just doing it on the other ones. So what you do is you just click on the graph wherever you want that dot to be. So go ahead and plot that dot. And then just like where we talked about it with the stuff we did before, you're going to plot each of those points that land on nice, pretty whole numbers. You do not need to plot dots at the ones that are not nice, pretty whole numbers. You don't need to plot decimals. You'll notice that as I move the dots around, that it's locking them. So it purposefully is not letting you put them at decimals, so you know you don't have to worry about it. Now, as you're plotting individual points on these, let's say you plot one in a place where you don't really want it. So it's like, oh, I missed. I need to get rid of that. You can actually click and drag that point to where you do want it to be. Or if you ended up with an extra one, you can actually drag it off the edge and then let go, and then it will disappear from it. Should you have to totally go back and redo it all, there is a clear all button here. If you click on that, then appropriately enough, it clears all. Each of the other problems that you're going to be seeing come up in this assignment work the same way. So just check to see, is it asking you to plot every point? Or is it asking you to pick the right graph and draw the curve? And as long as you're on top of those, you're going to be in great shape on this.